Hello Pre-Calculus, I've got a new video for you. It's lesson 3.2. It's very much the same as what we've been talking about already with domain. I just thought that these situations have another degree of complexity that perhaps we should just reserve our own little lesson for them. So, I'm talking about functions in which you've got a square root on both the top and the bottom. The whole thing is square rooted. So if you see that situation, you are instantly thinking to yourself, if it's underneath a square root, it needs to be not negative. So x squared minus 9 all over 1 minus 2x needs to be not negative, which means it needs to be greater than 0 or equal to 0. Now, if you think back to the discussion we already had in class with 3.1, as well as what we talked about in chapter 1, when you see a fraction that's being compared to 0, we need to list the critical numbers first. All right, so step 1, you're going to have critical numbers. And these will help guide you in these will help guide your intervals that you need to set up and test. So the first set of critical numbers will be gotten by setting the bottom equal to 0. So I'm going to call these domain critical numbers. The domain critical numbers are ones that need parentheses every single time. So you got 1 minus 2x equals 0. We could add the 2x to the other side. And then divide by 2. X equals 1/2. So x equals 1/2, when we put it in its interval, is going to have parentheses. The other critical numbers, I'm going to call those the zero critical numbers. Since we're always going to be saying greater than or equal to 0, when we're talking domain like this, it's always going to be roots. You can just instantly think these zeros are almost always going to have brackets around them because the equal to makes it inclusive. So that's me setting the top equaling 0. So you could add 9 and square root both sides. And make sure when you square root both sides that you put a plus or minus on the other side. We've talked a lot about that. I don't think I need to re-explain that whole situation. So x is equal to plus or minus 3 bracketed. X equals 1/2 parenthesized. Is that a word? Maybe. So now, step 1, done. Step 2, set up and test your intervals. So if you recall, we always start at negative infinity unless there's like a domain restriction where it says you can't be less than 5. Then it'd be like, okay, if I can't be less than 5, I'm starting at 5. So negative infinity would be our starting point. Always put parentheses around the infinite values. Our first stop is negative 3. Bracket. Now start again with that same number. We're moving to, our next stop would be 1/2. And we put a parenthesis there. Then we go 1/2. Next stop is 3. Put a bracket. And then 3 to infinity. All right, so we have to test 4 different intervals. We're just picking a point that exists in that interval. So I'm going to go negative 4 for this, 0 for that, 1 here, and then 4 at the end. And all we're doing at this point is we're taking those values and we're plugging it into this inequality right here to see whether or not it's positive or negative. So if I plug in negative 4, That's going to give me 16 minus 9, it's going to be positive, divided by 1 minus 2 times negative 4. These negatives, when multiplied, will cancel, yielding a positive value. All right, so this one looks safe. Because it's positive, this remains in the domain set. If you try 0, you're going to get 0 minus 9, which is a negative, divided by 1 minus basically 0, which is positive. A negative divided by a positive is a negative value. A negative value would not be greater than or equal to 0, so this whole interval is disregarded. All right, again, plug in 1 for wherever you see an x. 1 squared minus 9 is negative, divided by 1 minus 2 times 1, 1 minus 2, negative 1. That's also negative. Positive, it should be inside the domain. And then last but not least, 4 squared is going to be 16 minus 4, positive, divided by 1 minus 2 times 4, that's certainly going to be a negative value. So a negative doesn't work. So the domain of f, the places where all the x values can live, are from negative infinity to negative 3, and from 1/2 to 3. That's your domain. So please be clear in your final answers. So this would be a very good way of expressing your final answer. Your domain is going to be negative infinity to negative 3 with a bracket in union with 1/2 to 3 bracketed. There's our final answer. All right, so that was a lot going on there, but I think you guys can see my logic of, okay, we go critical numbers, set the bottom equal to 0, set the top equal to 0, and from there, that gives us our interval boundaries, and then we test them, and once we test them, we're done. All right, I only have one more example for you. What happens when you have to deal with two what appear to be complex roots that are added to or subtracted from one another? Well, what happens is we've got two inequalities. The first one says x plus 6 over x minus 3 must be greater than or equal to 0. We're going to have to do the whole rigmarole of that. And then over here, we have to say that 56 minus x squared is greater than or equal to 0. So there's going to be domain, we're going to have to do the intervals for both parts. And then we see, where do they share? Where do they share domains? So step 1, find your critical numbers. So your critical points or critical numbers. The bottom is going to be 3. Again, these would be DCNs or domain critical numbers. The top equals 0 is going to be a 0 critical number. So I'm going to put that in brackets because of the equal to. All right, test these intervals. Negative infinity to negative 6, brackets, parenthesis there. Negative 6 to 3, parenthesis. And then 3 to infinity. Pick a random point in between those intervals. Test them. Negative 7 plus 6, that's a negative. Divided by negative 7 minus 3, that's a negative. All right, so positive infinity works. 0 doesn't because it's negative. 4 does because it's positive. So if this were the only part to the function, our domain would be negative infinity to negative 6 and from 3 to infinity. But it's not the only part of our domain. We have to work in harmony with this one as well. So what we do to find critical numbers here is we set this equal to 0. And here's a good rule of thumb. If you ever see a negative in front of an x squared, divide both sides by -1. Okay, it's just going to make factoring a lot easier for you if factoring is possible. So if I divide everybody by -1, that would create a positive x squared, a positive 1x, and a negative 56. Oh, positive 8 and negative 7 give you positive 1. So there's a shortcut for factoring if it's just a clean x squared out front. That you know that, hey, the only way to get x squared through multiplication of factors is to get x times x. And we know that the multiples of negative 56 have to add up to 1 to make factoring possible. So it's going to be a positive 8 times a negative 7. That's what's going to make that factorable. So my critical numbers are x equals 7 and x equals negative 8. And they're both bracketed because we didn't have a domain critical number. It was just the equal to 0. Okay, these are both bracketed. So I'm going to go from negative infinity. Do I have enough room? Let's try it. Negative infinity to negative 8. Negative 8 to 7. And then 7 to infinity. So test negative 9, test 0, test 8. And actually, you know what? I can't plug it into this value because I divided by that negative 1. Dividing by that negative 1 sort of messes with things, particularly because of the inequality symbol. When you divide by negatives, it flips the symbol. So I'm just going to plug it into this right here. 56 minus negative 9 is 65, okay? Now it's going to be 65 minus negative 9 squared. 65 minus 81, that's a negative number. And we need it to be positive, so sorry about you. The 0, when you plug it in here and here, yields a positive. That's what we want. And then when you plug in 8, it ends up also being negative. So this is where a lot of times students, they just don't know where to go from here. Here's what you got to do. You got to ask yourself the question, what is the intersection or shared space of these and this? That's the question you have to answer in order to thoroughly, that's the question you got to answer the question. To figure out what the domain of this entire function is, it's got to be the intersection of these two. So maybe we can use a number line to kind of visualize this thing. So let's say I graph this part on a number line. We'll go by, 2s. 2, 4, 6, 8, 10. And over here I'll go -2, -4, -6, -8, -10. Okay. This solution set would be a closed circle at -6, and it just keeps going forever in that direction. The solution set for 3 to infinity would be an open circle at 3 and would go forever in this direction. -8 to 7, in brackets, different color in red, would go from -8 all the way to 7. So, the question is, so what's the shared space? Let's get a closer look here. What's the shared, oh, maybe too close. What's the shared space between the red and the purple? All right, I'm not sure if I can hold this and work on the whiteboard, so I'm going to set you down. Sorry if you guys got queasy right there. Bottom line, is the red and the purple occupy this spot right here from -8 to -6, both inclusive, okay? And it also occupies from 3 to 7. The 3 gets a parenthesis, the 7 gets a bracket. All right, so I know that was super intense. The 2 problems took us 16 minutes to go through, but I think it should make sense if you understand the idea of, I gotta find critical numbers, I gotta test those intervals. He's just saying if there's 2 different roots being added to or subtracted from one another, they gotta both coexist. Okay, I can't just throw them at the wall and be like, all right, all those are my answers. It's what they both share. All right, please come to class with questions tomorrow so that I can clarify as much of this as possible. Thanks for watching.